Hi, I'm Paul. We are doing Leetcode must-know interview questions, and today's challenge is permutations. Rated medium, given an array nums of distinct integers, return all the possible permutations, and you can return the answer in any order. It's a permutation, rearrangement of all the elements of an array. Okay, well, we're looking at an example of this. It's similar. It's similar to the last challenge that we did, which was combinations. The difference in the combinations is that we were given a range of numbers. Well, we were given a number n and asked to consider the range of numbers from 1 to n and how many combinations could we make of length k. We're given maybe n is 4, k is 2. How many combinations of two numbers from 1 to 4 can we make? And order is not important. So a combination of 1, 2 is the same as a combination of 2, 1. In permutations, the order is important because in each permutation we're going to have all of the numbers in the input array in all possible orders. So the numbers will always be the same, they'll just be in a different order. What else can we say about this? The length of the input array is between 1 and 6. That's good. Permutation algorithms are not fast. They're factorial algorithms. So the runtime is O of n factorial. And that's slow. What else? Like the combinations algorithm, we can do it with a depth first search. For example, here's the input 1, 2, 3. So let's say that we start with 1, then we go down to the next depth, which is 2, the next depth, which is 3, and we're out of numbers. All right, so we'll pop the 3 off. Now what can we do? Well, we don't have any more numbers, so we have to pop the 2 off. Now what can we do? Well, in this case, unlike the combinations, which we could always assemble strictly going forward, in this case, we are going to have to keep track of which numbers have been visited. So we can loop through these numbers in the array, but when we get 1, 2, 3 and then pop it back to 1, we have to be able to realize that 2 has already been visited and we can't use that as the next number. So we have to go to 3 and then we can go to 2. All right, then what? Well, we backtrack. So pop the 2, but there's nothing else we can do with 1 and 3. So we pop the 3, and really there's nothing else we can do with 1. We've exhausted the depth of 1, so 1 comes off, and we go to the next number 2 and proceed in that fashion. Anything else? I don't think so. Topics, probably backtracking. Yeah, backtracking. Okay, this is similar enough to the one that we did yesterday that if I just copy this code, I'll be able to save some typing, and we'll discuss the differences as we go. What am I putting in here? Everything in solution. Okay, let's copy that. Let's go back to permutations. Let's take, hold on, what did I copy? Did I copy that last bracket? I did, okay. So permutations, well, let's put it here. We'll have to patch it up anyway. All right, what do we need for class variables? So first of all, we don't need we don't need this. Well, we need this solution is called permute. So let's take that out of there and put it here. Now the class variables that we need would be well, yesterday we called them combinations, combos. I suppose today we could call them perms for permutations. We have an integer list current that we'll use to build up the current permutation. We don't need n and k. N and k was strictly for combinations. You know, how many combinations of k elements can you make from n numbers? So we don't need that. What we do need is we need, I guess the equivalent for what we're going to do would be to say that we need the elements array. Okay, and we'll just copy nums into that rather than passing it around. And the other thing that we need, as I said, was a Boolean array of visited, and this will be these will be indexes into the elements array. So a true in the Boolean array, a true at some index in the Boolean array will indicate that the corresponding index in the element array has been visited. All right. Now permute. Again, we don't need n and k, but we do need elements equals nums. Okay. Visited. I wonder if we could just we could initialize it up at the top like the array list, but let's just do visited equals new Boolean. You know what? We can't initialize it up at the top because we don't know how long it needs to be yet. So we'll do nums length. Visited equals a Boolean array of the same length as the nums array. DFS, we're going to send in 0 and return perms instead of combos. The DFS 0 means we're starting at index 0 of the nums array. In combinations, they gave us numbers from 1 to n. So it made sense to start at 1. In this, they're giving us an array of numbers, and it makes sense to start at index 0. All right, the first thing that we want to do when we come in here, I don't really like I as the variable here anymore. Well, let's call it index. Whoa, what the heck was that? INDEX. We need to check and see if we have a complete permutation. And we do it in a little different way than we did with the combination. If index equals elements dot length, what's going to happen? We'll have a for loop here to loop through the elements. We're going to loop through the elements in the nums array. Now, when that index, for example, in example 1 here, we will have numbers at indexes 0, 1, and 2, but we won't have anything at index 3. So when we get around to calling DFS with index 3, that means we've exhausted all of the elements in the array. I think that'll be more clear when we get to it. But if index equals elements dot length, then we will add the current permutation to the result list. All right. At this point, for int, I'm not going to use I because it's too close to index. But let's say for int j equals 0, j is less than elements dot length j plus plus. We're going to loop through all the elements. Let me scoot this over just in case. All right. Okay. If the element at index j is not visited, then we'll set it so that it is visited. Again, this is because we can't just build these up going forward. For example, in the 1, 2, 3, after building that up, we're going to pop the 3, we're going to pop the 2. We are still in the loop here, and so going forward, what is the next number? We need to know that we can't put 2 on there again. So we got to check and see if the number is visited. That's what allows us to do something like this, where we build up 1, 3, 2. By the time when we try to put 2 in here a second time, we see that it's already visited, and so we put the 3 in, and then we put the 2 in. All right, if it's not visited, then we will mark it as visited. We will add it to the current permutation that we're building up. And we will continue to the next depth, DFS index plus 1. All right. What's next? We have down here. So we're doing kind of the same thing where we do a current add, and then call the DFS at the next depth. Yeah, we're going to do something like this too. We don't need this. We don't need that. But we do need something like this. And that is when we come back from the DFS, we're going to remove, yeah, that's exactly the same. We're going to remove the last element. And we are going to set it, visited j, we are going to reset visited j to false because we just took it out of the current permutation. Let me see if I can kind of walk through what's happening here. So in example 1, DFS, we'll do DFS 0 for the index. Okay, so we'll come in here, index is 0. Is 0 equal to elements.length? Well, elements.length in this example is 3, so no, it isn't. Then we'll go through the loop for j equals 0. Is the element at 0, which is 1, Has that been visited? No. All right, so we set it so it is visited, and we add it to the current current permutation. So the current permutation, it now has a 1. And we'll call DFS with index plus 1. That is 1. We'll come back in here with a 1. Does 1 equal 3? No. All right. Come back in here, j equals 0. Is the element at index 0 visited? Yes. So we'll skip it. Next element in the loop, 1 is the element at index 1, which is 2. Is that visited? No. So we mark it as visited and add it to the current permutation. So the current permutation is now 1, 2. And we call DFS again with index plus 1. That is going to be 2. Okay? So come back in here with 2. Is 2 equal to 3? No. All right, come down here. For j equals 0, is the element at 1 visited? Yes. Is the element at 2 visited? Yes. I'm sorry. Is the element at 1? No. Is the element at 0 visited? No. Is the element at 1 visited? Yes. Is the element at 2 visited? No. That would be 3, so we put 3 in as the permutation. Mark it to true, add it to the current permutation, and call DFS with index plus 1. That would be 3. So we come in here, 3. All right, is 3 equal to 3? Yes. All right, so we take the current permutation, which is 1, 2, 3, and we add it to the result list and return. Right? So we come out of here, the DFS 3, remove the last element that was added. So now we're back to 1, 2, and we set visited at index 2, which is the number 3, to false. It's not visited anymore. All right? That actually ends the call to DFS2. So we fall through that, and we are back to, you know what, at this point it gets a little bit confusing. We are back to 1, and we are at j is equal to 1. So we come down here and we say for okay, yeah, j is equal to 1. So now we're going through the loop another time. J will go to 2. Is the element at index 2 visited, which is 3? And the answer is it isn't. So we add it to the permutation. So now we have 1, 3, and we're in the process of building up 1, 2. I'm not going to go through this any further. It's kind of difficult to keep track of the recursion stacks without writing them all down. But if you want to do that, you can do it. But this should work. I'm going to try running it. Compile error. Oh, okay. Let's do that. Am I closing that somewhere? Yes. Okay. Identifier expected. What is that? 21? I think that may be. Wait a minute. No, I don't know what that is. Hold on. Line 21. For int j equals 0, j less than. For, you know what? That may just be part of not having the bracket. Let me try it again. Compile error. Visited equals false. Okay. Run. All right, that's accepted. Go ahead and submit. Move this back a little bit. Okay. All right, where are we at here? 1 millisecond. Oh, that was good. I don't remember the runtime on the combinations being that good, even though it's almost exactly the same thing. All right, complexity. It should be n factorial. N times n factorial. It's weird how they give these. I don't think n times n factorial is right, but I mean, in any case, the n factorial would swamp out the n, so let's just call it n factorial. Is there anything else that I wanted to say about this? No, I think that's it. So that's permutations. You do permutations with a, if anyone asks you to do permutations, you do it with a depth first search. And that's it. Thanks for watching. Feel free to subscribe, like, comment, and see you next time.